I was on a road trip and
this one bolt decides whether your engine runs smooth or destroys itself, and most people tighten it wrong. This is your belt tensioner. Not too tight, not too loose. There is a very small window where it actually works. This didn't snap randomly. It was warning for days. Those tiny cracks, that's heat, friction, and misalignment.
in today's video, I'm going to share how to fix squeaky engine noise, especially when you turn on the AC. All of a sudden, my AC performance declined and a squeaky, squealing engine noise started up. So I was confused whether my AC compressor has failed or some bigger issue. But when I checked the engine bonnet, I could see the belt was slipping continuously. Before moving to the topic, let's understand more about belt drives and belt tensioners. So, belt drives are essential components that transmit power between the engine crankshaft to other auxiliaries such as the coolant pump, the alternator, the air conditioning compressor, and other vital needs of the engine. So what happens after a certain amount of wear and tear, these belts tend to slip over the pulleys and create the squeaky noise. However, there are some other reasons as well that can contribute the squealing noise, such as if there is any wear and tear in the bearings or in the entire assembly itself may have some defects or damage. In those cases too, the chirping and squealing noise may come. But in this case, in my car's issue, it is due to the belt slippage. So how I figured it out, that's the main cause. We are going to discuss that to inspect what's happening there. So I could notice the compressor pulley was not spinning same as that of the drive. The belt was slipping over the pulley and it kept on slipping and rotating, spinning and slipping. It was not consistent. And that's how I get to know the belt, it's not getting the drive.
We start by loosening the lock nut, which frees up the tensioner. Then we move it to its loosest position. So removing the old belt and installing the new one becomes much easier. Initially, I didn't have a box ratchet wrench, so I tried using a ring spanner. But as you can see, it tends to slip, and that can easily damage the bolt head. Once the head gets rounded, it becomes very difficult to loosen. So I switched to a ratchet box spanner. That gave me much better grip and control, making the job quicker and safer. Using the same tool, I then loosened the tensioner and brought it to its fully relaxed position. Here is the snapped belt, and this is the new one. You can see the difference, cracks, wear, and complete failure. Now let's install the new belt. Space is pretty tight in here, so it takes a bit of patience. I'll show clearer angles in the next clip so you can follow the routine properly. And just like that, I placed the belt among its pulleys and installed it in its place. Now, the moment of truth. Engine on, AC on, no chirping, no abnormal noise, just a smooth, clean run.
Now it's cooling really well.
At the moment, the compressor is freewheeling with the pulley. Once the AC is turned on, the electromagnetic clutch engages, coupling the compressor to the pulley. This adds load to the belt drive, and you can see it's handling it without any slip or noise. This is where weak belts usually start slipping and give that chirping noise, but this one holds it perfectly.
बच्ची कहीं घूमने जा रही है लगता है. कहाँ जा रही है? घूमने जा रही है. चलो बैठ जाओ, बैठ जाओ, बैठ जाओ. बच्ची घूमने जा रही है, बड़ी खुश लग रही है. वो बैठ गई.
Before their invention in the mid 80s, it was a hectic task to adjust belt tension. The technician had to take apart the all assemblies, adjust each and every pulley so that the recommended belt tension was achieved, and it required a frequent adjustment as well. And there used to be issues where the belt entirely run out from the pulleys, and that caused a lot of issues. But ever since their invention, it became much easier to adjust belt tension. So basically we have got three types of belt tensioners. First and the most common one is a spring-loaded belt tensioner that automatically adjusts the belt tension with the help of a swing arm. On top of we have an idler pulley that remains in contact with the belt. Next popular is the hydraulic belt tensioner. Here, instead of a spring, a hydraulic piston cylinder arrangement actuates the swing arm movement, which controls the belt tension. These are mostly used in premium cars, the V8 and V6. So there it provides a much higher belt tension compared to the spring-loaded ones. And both of these construction are a lot similar. There we use spring, and in this one we make use of hydraulic piston cylinder. However, in case of any damage or wear and tear, it is recommended to replace the entire assembly than repairing it. And the final and cheapest one, we have the manual belt tensioner. These can be adjusted with the help of an adjustable bolt and a lock nut. We have to loosen the lock nut and adjust the bolt until the right amount of belt tension is achieved and lock it back in its place.
With the lock nut loose, the tensioner moves freely. This is the fully relaxed position, maximum slack in the system. This free movement is important. If the tensioner feels stiff or stuck here, that's usually a sign of wear or internal damage. A healthy mechanical tensioner should move smoothly without binding or any play. Now with enough slack available, we can route the new belt. Always follow the correct pulley path. One misalignment and the belt will wear unevenly or slip. Make sure the belt sits properly in every pulley groove. Even a slight offset can cause noise and premature failure. At this point, you can see the belt isn't going on easily. That's because the tensioner isn't fully relaxed yet. There is still not enough slack in the system. So we loosen it a bit more until we get maximum movement from the tensioner. This extra slack is what allows the belt to sit properly over all the pulleys without forcing it. Never force the belt into place. That can damage the belt or misalign it on the pulleys. Now with enough slack available, the belt slides into position much more easily. If the belt doesn't go in easily, it usually is a tension issue, not a belt issue. For this engine, you're looking for about 8 to 10 mm deflection at the max, at the longest span of the belt with moderate finger pressure. There is no exact gauge used in most cases, so it comes down to feel and proper method. A lot of people over tighten this belt, especially thinking tighter is safer. But on Alto 800, that puts extra load on the alternator and AC compressor bearings. If the belt is slightly loose, you will notice it immediately when the AC is turned on. That's when the chirping or squealing starts. So the correct way is set the tension just enough so it doesn't slip over AC load. After setting tension, always check it with the engine running, especially with the AC turned on. If there is no slip, no noise, and the belt runs stable, that's the correct tension. Also recheck the tension after a few days of driving. New belts tend to stretch slightly after initial use. On this car, correct tension isn't about force, it's about balance and under load. Now everything is back together. This is how the car should feel on road. Smooth, quiet, and effortless. A small component like a belt doesn't look important, but it drives critical systems, your alternator, water pump, AC compressor. And what most people don't realize is the belt itself is rarely the real problem. In most cases, failure starts with something else. Incorrect tension, slight misalignment, or a worn out pulley bearing. That's why just replacing the belt without checking the system often leads to the same issue coming back. On cars like the Maruti Suzuki Alto 800, the setup is simple, but that also means everything depends on how accurately you set the tension. There is no automatic adjustment here. It is completely manual, which means precision comes from understanding, not guesswork. A properly tensioned belt should run silently, handle load without slipping, and sit perfectly aligned on every pulley. If you ever hear a chirping or squealing sound, especially when you turn on the AC, that's usually the first warning sign. And that's the best time to act, because once it starts slipping under load, heat builds up quickly and the friction and the belt begins to wear much faster. Another thing people overlook is rechecking the tension. A new belt tends to stretch slightly after initial use, so it always a good idea to inspect it again after a few days of riding. Also, never over tighten the belt thinking it is safer. Excess tension puts unnecessary load on bearings, especially the alternator and compressor bearings will wear out faster, and that again will be a costly repair. And those failures are far more expensive than replacing the simple belt. So, in the end, it is not just about fixing the problem, it is also about understanding what caused it in the first place. That's what keeps the car reliable and saves you from bigger issues down the line. If you found this video helpful and enjoyed detailed, real world mechanical work like this, consider subscribing. It genuinely helps and keeps me motivated to create more content like this. If your car is making that small noise right now, don't ignore it. You already know where it leads.